Using percents and proportions review. So right here we're going to go through, this page has the first three ways that we're going to apply proportions, use proportions to solve problems. So use one is scale drawings. Let's look at the example. A map is shown on a scale of 1 inch equals 3 miles. If Townville is 18 inches away from Cityburg on the map, how far away are the actual cities? So we're going to go from a map to an actual world distance. So our proportions set up for scale drawings is we write two ratios. One of them has the scale. That means basically what equals what on the scale drawing equals what in the actual world. And we have our measurements, the actual measurements between the two things we want to find the distance between on the scale. So let's start with the scale part here. Now, oftentimes this will be written as something equal to something else, even though we're going to change it to a ratio of something over something else. So let's look at this. 1 inch equals 3 miles. Now, which of these goes on the scale and on the scale drawing, and which of these is the actual object? Well, because this is a map, hopefully my map is going to be in inches, and my real world is going to be in miles. So I'm going to put the inches on top here, 1 inch, and the 3 miles in the actual object side. So 1 inch on the scale drawing is 3 miles in the actual world. Now let's look at the measurements. What measurements am I given here? Well, I'm giving that Townville is 18 inches away from Cityburg on the map. So is my 18 inches going to go on top here with the scale drawing or on the bottom with the actual object? Well, hopefully these two towns aren't actually 18 inches away. I think that's going to be on the scale drawing, 18 inches. And then my actual object, how far away are the actual cities? So that's going to be my unknown. I'm going to put an X there because I don't know what it is. From here, I can solve the proportion. So right now we're just doing setups. We'll go over on the next page how to solve. So this will be a setup for scale drawing. The scale, 1 inch, is 3 miles. And the measurements, 18 inches on the map, at a certain distance in the real world I would need to find. All right, let's go on now to the unit conversion setup. Here's the example. Use a quart-sized container to fill up a 5-gallon bucket. How many quarts equals 5 gallons? Well, on a proportion setup for unit conversions, and there's other ways to do unit conversions, we're going to go over the proportion way to do it. We need to figure out the unit ratio. Now again, oftentimes this will be written as something equals something else, even though we're going to write it as a ratio, something above something else, something over something else. So let's see. You can look on your formula chart and find out that 1 gallon equals 4 quarts. Okay, so if that's the ratio I get from my unit conversion, from my ratio chart or conversion chart, I'm going to use that as my unit ratio. 1 gallon equals 4 quarts. All right, so I got 1 gallon equals 4 quarts. Now I need to find out what are the measurements I'm giving from the problem. So my measurements from the problem are 5-gallon bucket and how many quarts. So 5 gallons. Now I'm going to have to match that up with the gallons. So I'm going to put 5 gallons for my measurement. And then how many quarts? I don't know. That's where I put my X. Okay, so unit conversion proportion setup. Find out your ratio from your conversion chart. A gallon equals 4 quarts. And guys, it really doesn't matter what you put on top and what you put on bottom as long as it matches up on the other side. So if I have gallons on top, I need to have gallons on top over here. If I had quarts on top, I need to have quarts on top over here. All right, as long as they match up. Okay, lastly, percents. There's actually one other way we're going to do similar figures later, but for right now, percents will be the last one we go over. Now, a percent setup is part over whole equals percent part over 100. All right, so let's take a look at the problem and see if we can pick out these things from the problem. Example, of the students at a school, 65% ride the bus. If there are 600 students at the school, how many of them are bus riders? Okay, so let's look at the numbers I'm given. One number is a dead giveaway. 65% ride the bus. All right, and I'm asking about how many of them are bus riders. So that's going to match up with my percent part. I'm going to do in blue here. So 65% ride the bus, and I'm asking about what percent are bus riders. So I know that 65% needs to go on my percent part. Okay, now we need to figure out if the other number I'm given is the part or the whole, and which one is going to be my unknown. Now this 100 is always there. So this 100 is a dead giveaway. It's always 100 over your percent part. I just need to find out if this other number I'm given in the problem, is that going to be my part or my whole? So let's take a look at it. If there are 600 students at the school, how many of them are bus riders? Now, which is my whole? The total numbers at the school or the bus riders? Well, bus riders are going to be the part, and the whole is going to be how many students are at the school. So if 600 students at the school, that's going to be my whole. Okay, and my part is going to be what I'm looking for. How many of them are bus riders? That's my unknown. Okay, that's my unknown. That's going to be my x. All right, so let's see what this looks like when I write it out now. So my part is x, and my whole is 600. All right, and that's equal to 100 on the bottom, and my percent part is 65. Okay, now let's look at how this matches up. 100% is the whole, like 600 is the whole. 65% is the part, just like X, the bus riders are going to be the part. So notice things match up across. All right, so that's a setup for percents. Now let's go on to how to actually solve these proportions.